So, good morning, everyone. Welcome to the second Argo Workflows and Events community meeting of 2021, which it turns out is exactly the same as 2020, which is probably disappointing. We've got a pretty good agenda today. I'm pretty excited about some of the things that we're going to be talking about today. We're going to be talking a bit about infrastructure automation with Alexandre from InsideBoard. And we're also going to have a presentation from Angao. He's going to talk about how Tripadvisor uses Argo for their MLOps exercises. Derek is going to be talking a little bit about some of the upcoming features in Argo Events related to some new Prometheus metrics for people who are wanting more monitoring on that. And then we're going to talk a little bit about some of the changes that are coming in Argo Workflows 3.1. So Simon is going to talk to us about data templates. I'm going to do hopefully a little demonstration of the emissary executor, and Bala will be talking about conditional artifacts templates. And I'm pretty excited about this because we're kind of filling out some of the areas and the product features that we haven't got around to before. Now we are recording this, and the recording will be shared on YouTube if you want to share that recording with your colleagues or come back and reference something later on. That typically takes about 24 hours to get sorted out. If you want to ask a question at any point during the session, you can either just ask out loud or you can ask in the chat room. Both of those are fine ways to do it. If you ask in the chat room, we'll probably just read out loud what the question you asked at that point. It's awesome if you could add yourself to the attendees list so we can know who's joined us and where you guys have come from. And before we start, does anybody have any questions or queries? That sounds good. Alexandre, are you ready to start?
Hi, yes, I'm ready. You hear me well?
Yes, you sound great. Thank you.
Okay, perfect.
Okay, I'll let you take over the screen share.
Okay. Okay, is everybody seeing my screen? And I will have some few slides. I will go straight to the demo. We will talk about infrastructure automation on how we use Argo at InsideBoard. First of all, I want to talk about our background workflow at InsideBoard. We are a startup born in 2016. And we aim to automate everything from the infrastructure to the product. Our infrastructure is today fully cloud agnostic, and we deliver dedicated cloud resources for all our customers. 1 year ago, we moved all our Kubernetes job applications workflow from StackStorm to Argo. I don't know if anybody knows StackStorm. It's a good technology, but the pain point is that it's not Kubernetes native. After that first migration, the ops team decided to move all the infrastructure StackStorm jobs to Argo. Why we decided that? The first is the GitOps way. Argo is Kubernetes native, so it is very easy to manage all our workflow with a tool like Argo CD. And the second, obviously, is that we do not want to maintain multiple technologies for, in fact, the same goal, doing workflow, starting jobs. With that said, I will show you the our provisioning dedicated cloud resources with Argo, and we do it with Terraform. This is a small picture of our provisioning workflow. Okay, so I will go into the detail during the demo of all the steps of this workflow. I will also give some tips on how we use Terraform with Consul on Vault, on how we use everything with Argo. Okay, so let's start the demo. Okay, as you can see on the first part, and I told you that we deliver dedicated cloud resources for all our customers. So the first thing we will do is adding a new customer in our dev environment. Okay, to do so, I have just coded a small interface to do so. So let's create a new customer. We will just call it Argo. We'll add a new vhost, Argo, and we want dedicated resources. Okay, the new customer is declared in our infrastructure. And what the UIs have done, just okay, register the new customer Argo in a Consul KV store, and it has also produce a new message in a Terraform topic. And with that message, Argo will consume the message and then trigger the Terraform workflow. Okay, so we can see that we have now a workflow running. And first of all, the workflow send a Slack message to do some notification to the ops team. And something interesting is that now we have all this workflow is now part of our CI of the infrastructure code. Okay, so now you can see on the diagram when the workflow started, it's doing a Terraform plan file. Okay, here you can see that I've put some logos. You can see GitLab, Vault, on Terraform, of course. To get all the secrets part, to be able to launch the Terraform plan for the cloud providers or etc., we inject sidecar vaults. And as input of the workflow, we have a GitLab repository. Okay, so let's see if everything is okay. Now we can see that Terraform will create two new availability sets, one for the MongoDB replica set and one for the web servers. It will create also a new storage account on Azure. We named it Argo, like our customer. We also add a new blob storage container, and we will create this manifest. And this manifest will be interesting afterwards. It will create a new custom resource definition in Kubernetes, and we will see that we have another Argo Events listening on these new custom resources. And we also declare we will store in Vault all the sensitive data from the storage account. So the clients or the backend or of the application can just use it from Vault. Okay, so let's resume. Okay. So now we are going to apply the Terraform plan. We are here, and you can see on the plan that I have a link to the Consul KV store. We saw earlier that we store the new customer in the Consul KV store, and we can see here that we have a GitLab repository as input artifact. And in fact, at InsideBoard, we manage all our Terraform script with Ruby on Consul template RB that will render all the Terraform scripts from Consul. And now we can see that we have two new workflows. And those workflows are the one that will bootstrap the new virtual machines. We have one workflow for our new MongoDB dedicated replica set for our new customer, and we have also a new workflow for the web servers. Okay, so we can see that everything is on the way. Can be a little bit long, so while it's building, I want to show something we really like to do with Argo on all the events. Okay, let's say I want to add a new customer. Okay, let's say we, here you can see, in fact, our Terraform script. It's all Ruby code, and it's rendered then in the workflow. Let's say we want to add a new blob storage container for all our customers because of a new product feature or something else. Okay. Okay, git push. Okay, now we have updated the Terraform code. Now we don't want to go to the UI I showed you earlier. We just want to launch a new workflow, a new Terraform workflow. Okay, so that is something I really like, is managing all our infrastructure with some echo commands. And that's it.
Thank you very much for that. Now, does anybody want to ask any questions about this before we move on? Okay, cool. If you do want to ask any questions, of course, you can just do that in the chat, or we can circle back around to this later on.
Yes, I hope I'm clear enough with my French accent.
I think it was clear enough. Okay, Ang, are you ready to take over?
Yeah, sure. Can you hear me?
Yes, I can hear you very well. Thank you.
Okay, great. Okay, I'll share my screen. Okay. Can you see my screen?
Yes.
Okay. Hello, everyone. My name is Argo. I'm a principal software engineer at Tripadvisor, and I'm on the machine learning infrastructure team. Today, I want to talk about how we apply MLOps at our company and how we do CI/CD automations with help of Argo projects. To start off, so as a travel company, there are a lot of places we can apply machine learning techniques, and I just give you some examples where we apply machine learning models. For example, in this graph, you can see we normally do the recommendation-based model or some sorting-based model to rank, say, the hotels or restaurants. And also we do some smart bidding for the auction-based models. So that's where we apply those machine learning models. And for the MLOps at Tripadvisor, for our team, we work closely with data scientists across our company to provide them a common infrastructure so the data scientists can deploy or train their model easily. And we heavily apply the DevOps principles to our ML systems. And at the core of it is the CI/CD pipeline for automate all the things. So I want to give you some background on what exactly ML lifecycle is. So normally when the data scientists plan to build a model, they start with the design phase, and then they will do some offline training in some testing environment. And once they finish the training, they will deploy the model to a staging environment, normally in our staging cluster. And then they can do some, say, the offline experiment with the model they deployed in our staging environment. And once they verify the model behave as expected, they will deploy the model to our production environment. And then we have some tools for them to analyze the performance of model. And then based on the feedback, they can either improve the model or deprecate some old models. So this is whole ML life cycle. And for our team, we are actually involved in all these stage, starting from the training till the deployment. And as part of this ML life cycle, there are several components involved, like data collection and ingestion. And another big piece is feature store that will basically provide the feature data for the data scientists to train their model offline or provide the features online for their model prediction. And also experiment tracking is another big piece. So the data scientists will do lots of experiments offline, and we need a central place for them to basically track their experiments and provide them reproducibility to be able to easily reproduce the model they have been built. And also there are like a model image building and evaluation components we provide to the data scientists so they can leverage all of this to control their ML life cycle. So at the core of all these ML life cycles is actually the CI/CD pipeline. And we heavily use a lot of open source projects. So we apply GitOps, continuous delivery with the help of Argo CD. And for the ML pipeline automation, we use Argo Events together with Argo Workflow, actually for both our like model building and even the offline and batched prediction. And for the machine learning lifecycle management, we use MLflow. That's another open source tool. And for the machine learning model deployment with user tool called Southern. Most of these tools are cloud native, so it can be easily run in the Kubernetes environment. Okay, so our journey to the MLOps started nearly 2 years ago, and it's been a great success. So now a data scientist can easily deploy a model from their notebook into the production environment with a few clicks. So everything is automated, and it actually frees the time for the engineering to do more interesting work, and also the data scientists can do experiment with their model more easily. So this is the platform overview, how our architecture looks like. The real architecture is actually more complicated than this. I did some simplification. So as you can see, the data scientists start from here. They normally interact with a Jupyter notebook for the model training, and they will defining the features with our in-house feature definition. So we have a central repo for the feature definition. And then once they define this feature, they will able to use the offline feature store for offline model training. And also this feature will automatically provide to them as a feature service for online prediction as well. So this help us make sure whatever the data they use to train the model actually is the same they use for prediction online for data consistency. And once they are satisfied with their model, they can register their experiment with MLflow tracking server. So the tracking server will track all the experiment the data scientist has made. And when they satisfy the experiment, they can register the model. And as part of the model registration, it's actually kick off a pipeline for, say, the image building. And also we do some testings for the model as well. We will talk detail how this pipeline works in the later of the presentation. And the next stage is the model deployment. So from the model registry, they can, by few clicks, they can deploy the model either to the staging environment or the production environment. And also, as of now, we provide say the canary deployment or shadow deployments for the model as well. So that makes sure the model doesn't affect the real traffic for the user. And also we provide a quick rollback as well. So this is the runtime. We use, like I mentioned, we use Southern, and also all the Southern model service is part of our service mesh. So it's actually talk to our feature service in Kubernetes and through Istio. And there are some monitoring we provide to the data scientists by using promises. So all the models metrics are collected by promises, and we have some alerting for all the models, and we also provide auto scaling for the data scientist model. So let's take a look, deeper look on how exactly the where Argo product fits into all these pipelines. So for the model registry, once the data scientists register their experiment in MLflow tracking server, they can say, this is the screenshot of how the page looks like. They can select the model and then register their model by providing a name for the model or use some existing model. And this is how the pipeline actually triggered. We have a MLflow SQS plugin. It actually will send a event whenever the data scientist register a model, and Argo Events will pick up this event and then trigger the Argo workflow to do actually this pipeline. And as part of this pipeline, it involves, say, send a start notification to the Slack of the data scientist, so he knows when the model start building. And then once the model finish building, we do some heavy testing on the model to figure out the, say, the CPU usage or memory requirements for the data scientist model, and also the latency for the model and also the throughput. So all this info will get us to generate the deployment YAML file at the later stage. And once all these pipelines finish, we write back all these meta info as MLflow tag back to the MLflow UI, so the data scientist can view the some of the meta info, like what the model image is and which Argo workflow built the model, and also some testing reports. They can see how their model performed. And if they satisfy their model performance, they can actually deploy the model. So this page actually shows a list of all the models. So from this UI, we can easily see which model are in production by using this column. And we see what version of the model are in production and what version of the model are in staging stage. And also at the model description page, the data scientists can also provide some like description for their model or text for their model. So once the model is registered in MLflow, the next step is to deploy their model to the staging environment. So this is how they do their work. From the model register UI, they can change the stage of the model from none to, say, staging or production. So if they change the stage to staging, that means as part of the pipeline, the model will be deployed to the staging cluster. And this is also managed by the Argo Events and Argo workflow. So like before, there will be a SQS event sent to the SQS and the Argo Events will trigger a pipeline. And this time, we will generate a deployment YAML file for the model. And as this deployment YAML file will be checked into the GitLab. And then we have a homegrown small app called a Model Manager. And this app actually just calls the Argo CD API to create the Argo CD application. And then all the rest work will be managed by Argo CD for GitOps style management. Yeah. And this is how the deployment looks like. So we have a custom model deployment operator, basically abstract the Southern deployment. And under hood of this deployment, we use Southern. So our operator actually create a Southern deployment. And this deployment also abstract away some of the detail, like how we do Istio routings and some other complex stuff. So make the deployment YAML file more easier to understand and reason about. Yeah, so this is an example of the Argo CD application created by our pipeline. And yeah, I think that's pretty much okay. And also we have the, we also utilize another tool called Kita. So Kita basically provide us the ability to auto scale the model. For this example, we will auto scale the model based on the number of requests to the model. And this threshold is also actually figured out by part of our pipelines as well. Yeah, I think that's everything I want to cover. Are there any questions?
You're triggering the model rebuild based on the event that comes out of MLflow. So I've seen a lot of people just like, fire up a notebook ad hoc and go and register a model themselves. But how are you getting the information out of MLflow to define, how one ought to build that thing?
I'm not really get what your question is. So
what is on the SQS topic in that slide?
Oh, yeah, yes. So right now, I can't exactly remember what in the message, but I think we have the ML flow run ID, so it will allow the Argo workflow to basically read back all the meta info from the ML flow. So ML flow also has a REST API. So as long as we know the run ID, we can get all the info from the ML flow server itself as well. And then the workflow itself will, based on those info, figure out what to do next.
Okay, and then you just populate all the metadata in ML flow for what to do. Okay.
Yeah.
Do you plan to open source your operator?
This one, yeah. Right now, we don't have plans to open source it because it's actually coupled with our infrastructure a lot, like especially the istio part. Yeah, but I think some part of it might be able to open source if it's general enough. And also, we used to have a talk with the Southern team as well. This actually like a simplified version of the model deployment YAML, comparing to what a normal deployment YAML file will look like.
How many models do you train and serve a day?
Now it's I think around 100. I don't have exact number. It actually has it will become more and more every day. I think about 80 or 70 or something around 100.
What kind of, if you can answer this, what kind of things are those models trained to do?
It's basically like a prediction of basic scoring or like recommendation. So that's what our company mostly do for the machine learning, like recommend a hotel or restaurant for you, or rank the hotel or restaurant for you.
I have a question. Can you hear me?
Yeah, sure.
The question is about the, do you see any limitation to run your workflow in a single cluster? Since you have like maybe you have some different scalability requirement?
Right now, we don't hit any scalability, and we are actually really satisfied with the feature Argo workflow and Argo CD provide to us. I think the only issue we encountered is for some long running offline training pipeline. Sometimes we get some timeouts due to maybe the network issue or some glitch of the network. And that's the only thing we experienced. But for now, we don't have any scaling issues.
If you can share, like, how big is your Kubernetes cluster used for running such task?
For that, I'm not sure I'm allowed to expose those.
That's fine. Thank you. Yeah.
Sorry. Yeah.
I have a question. So you talked about performance testing, and I was very interested in that. So I'm pretty sure you're not doing long running performance tests. You're probably doing like tests to just check the threshold to see that a certain response is like in the mean of some kind of 500 milliseconds or less or something, or how is that happening, if you don't mind me asking?
Yeah, so that actually happened as part of the model image building pipeline. So once we have the image, we have another tool. It actually create let's say a deployment of your model, and then it start another like load testing. There is open source tool called Vigata. So we use that for load testing the model by sending some sample requests heavily to the model. And then based on that, we figure out the memory usage and CPU for the model, and also like the threads throughput or latency your model might be in the production environment.
Okay, thanks. And what was the name of that tool? Can you spell that? So
yeah, I can share you in our Slack channel later. It's called
thank you.
Yeah, we got it.
Okay.
Awesome.
Okay, thank you.
Ang, thank you very much for that. Does anybody else have any more questions? Excellent, excellent. Okay.
Okay.
So up
Thank you.
next, go for it.
Yeah. So is it the question for ML flow, or I can ask for the previous session also? That's what was giving that Terraform workflow. With
Yes, go for it.
Yeah. Okay. So whatever the Terraform workflow engine, he showed that automated through the Argo. Is it take care of the remote bucketing? Remote state file?
Yes, totally. In fact, in the diagram, I show that we inject some vault secrets, and everything Terraform needs is in Vault. In fact, so I can show you the provider config if you want.
Yeah, can you share?
Okay. This one. Okay. I think, yes, the code is there. That's all we have in the provider itself. So the TF state is on a blob storage. Everything you need, in fact, is in the vault secrets, and we inject those in the pod. I can. I wrote some post about it. There is more detail on the code on Medium. I can share you afterwards if you want.
Sure. If you, it will look good if you can share this, whatever the demo code you have it. Yeah.
Okay. No worries.
Alexandre, Ang, if you guys want to share any more information, slides or additional stuff, then send it over to me and I will add it to our document so people can go and find it.
Okay.
Yeah, we'll do.
Okay. We'll do that.
Cool. Okay.
Yeah, cool. It was a great demo. Thanks, both of you.
Thanks.
So in our next section, we're going to just talk about some upcoming features in Argo workflows and in Argo events. And Simon has asked to go first because I think he wants to demonstrate some stuff and get some feedback from you guys and gals. So Simon, are you ready?
Yes, I am.
Go for it.
All right. Can you see my screen? Yes, awesome.
Yes.
So hi, everyone. I'm Simon. I'm an engineer here at Intuit, and I obviously work on Argo workflows. Some of you might know me already. So I wanted to present this new template idea that we're playing around with called the data template. So the motivation of this data template is essentially, we know that it's very common for users to run a pod that downloads some data from an external source and then just pre-process it in some way. And what we want to do with this data template is essentially provide first-class support for that common operation of sourcing and transforming data, so that users essentially don't have to necessarily write their own containers. And even in some cases, they don't even have to run any containers at all. I'll explain what that means in a little bit. So yeah, so here's our goals with this data template are essentially to provide a set of sources and transformations for our users as convenience, and to be more importantly, to be able to sort of automatically decide if we are able to do the transformations that the user wants in the controller's memory. So for example, maybe a user runs a step that generates a long list of CSV lines or whatever, and they just want to do a simple find and replace or a simple filter. What they would have to do is either write a container that spins up and just does that very trivial idea. But with data template, for example, what we want to do is we want to give the user the ability to specify that on the workflow themselves. And if the controller sees, oh, these guys just want to manipulate a list of strings, we can do that in memory. So we don't even have to start a new pod for them. That's essentially what we're going for. We want to have an experience similar to, I'm sure all of you have used Bash before. So similar to piping, essentially. So in this example here, we source some information, like the context of this file, and then we could just pipe some greps, some seds, some sorts, some uniques. And that's, I mean, as a developer, this is very convenient. It's very easy and quick to do. You don't have to write Golang code or Python code to do these sort of simple, quick monolithic transformations. So this is sort of what we're aiming for. We don't want to obviously write a programming language. That's the whole point of containers. But we also want to give you some tools that for common use case that we hope that you're able to sort of assemble in such a way that provides like actually a lot of utility for you. Some maybe goals that we have, maybe we might want to use this engine to do like very quick inline modifications. But I don't think we're going to end up doing this way. Like I said before, our goal is to do large amounts of data transformations, not quick inline changes. So Alex is actually working on something. That would accomplish this. So if you're interested, I suggest you take a look at 5115. And also a non-goal that we have is we don't want this to be too small, but we also don't want this to be too big. There's obviously a point where a user may have requirements that are too specific or too unique to their data that they're just going to have to write their own container, and that's obviously fine. We don't want to substitute the idea of containers. So let's run through an example. This is sort of what we have right now of what the data template could look like. So you can see here that this is a template, and instead of container or script, we have data. So in this particular data template, it includes a source. So if you remember, we have essentially two types of contents for a data template. We can have one source, which is this cat, and then unlimited number of transformations. So this one in particular happens to have a source, and this source is something called with artifact paths. So the idea behind this source is that Argo will open up this bucket in S3, and it will essentially get you a list of all the file paths that are in that bucket. So that could be useful, for example, if you have a bucket with all of your storage for all your files for your project, and you want to, for example, only process files that are part of a certain project, or that are part of a certain model, or a certain date, or a certain, I don't know, you name it. So what this does is this actually opens up your S3 bucket, looks at the files, and then just returns all of the files down now to the transformation step. So we have a source step, now we have a transformation step. And the transformation step is essentially, like I mentioned before, it's all of these little programs that run in sequence to each other and can pipe into each other. So our first transformation is filter. So we only want to keep the files that have, in this example, this project name. Now, after the transformation is done, we essentially transfer the data. So the data outputted by this transformation to the next one. Maybe now we know that we only have only the project name files. So we want to just get rid of the project name. We don't need it anymore. And lastly, we have this transformation called group. So the idea is that maybe this returns 250 files and you want to process them in 25 pods. Well, group is a very convenient way to create batches of 10 files at a time. Now you can use the results of this template in another template that runs with items. So if you remember, with items, we'll automatically expand and create the pods, one for each item that you have, and each item could be a list. So this, so the dependent of this data template could be a with items container that expands into 25 containers, and you process each of the 10 files in parallel. Up to this point, do we have any questions? All right, in that case, I will continue. So in this example, we have a source. So this actually since we have a source and this source has to make a network connection and it has to download some file names, that's essentially going to run in a pod, right? We don't want to run this in memory. But you can also have a data transformation that doesn't have a source, a data template that essentially just does this little quick and easy sort of filters and maps and groups. That can be done in memory. So here we have another data template. You can imagine that we first call this main data template, and then, like I mentioned before, it expands to 25 pods. But now this data template can fan in and essentially take in the results of those 25 pods. And it does so through, you guys will be used to this sort of input parameter pattern that we have in Argo. So since this data template doesn't actually source anything from the outside world, it sources just from materials that are already in Argo, we can actually run all of these transformations in the controller memory. So this will immediately process the information without having to wait for a pod. That's one of the large benefits that we see with this data template, to be able to do this kind of stuff without even starting a single pod. So to continue our example, let's assume that our processing created a bunch of logs that we're not interested in. So we have run a filter to exclude those logs, any file that contains the log. And let's say, for example, that now that we have all these files, we want to group them by extension. So here we have a regular expression. In case you're not familiar with regular expressions, this particular regular expression will group by the extension of the file. And maybe you want to zip Python files in a different way that you want to compress video files or whatever. This could be a useful way to do so. So that's essentially sort of the spec that we are working with right now. And I just want to open up a few questions sort of for discussion if you guys have anything in mind. And if you guys don't have anything in mind, you're always welcome to visit 4958 and then just comment any sort of ideas that you have here. And I'll obviously we'll discuss. But the main question that we're interested in discussing, and I think it's the only one that I'm going to open to the group, is how do we provide a list of tools, groups, and filters, so just in a way that they're very extensible to the user, and that we don't have to actually implement each or enumerate them ourselves. Like what we don't want is to have to create a list of useful tools so that our users can just see it and start using them, so that we have to maintain that list. What we want is some way that we can very easily maybe load one library, or maybe provide access to sort of the common bash tools that are running the pod or whatever, that we don't have to essentially maintain this list. So with that question, I'll open up to answers to that question or any other question that you guys may have.
This is still draft.
Yeah.
When do you think we can play with this?
Yeah, so we're targeting for this 3.1, and which will be, I'm not sure what the schedule will be, but it'll be the next J release that's not 3.0. So it'll be in 2 releases. But if you guys want to get your hands dirty with this as soon as possible, I can always make a dev build and just share some images.
Also, in general, do people think that this would be useful for them? Like, is this this is a use case that I imagine people having trouble with, like not being able to do simple transformations in workflows. But I just wanted to, get some validation that this is a feature that people would actually use in their workflows.
Well, historically, doing ETL stuff in Argo workflows has been about the same amount of support as you get with like Bash, right? Where you end up having to do all of the heavy lifting bits yourself. This seems like it would be more pleasant if it fits.
I wonder if we could have a bit of a scripting language. It's just a bit of a wondering I've had today about, one of these step transformations could be kind of scripted. The question, of course, then is what is that scripted language? Simon, I don't think you talked enough about the kind of potential sources of data for this as well. Did you want to talk a bit more about that? Yeah. So yeah, like I mentioned before, we have the idea of data sources. In the example that I have, and the only one that's actually currently implemented right now is to get artifact paths. But we also imagine things, for example, like an HTTP request or a curl or a find to get a list of files in a specific way, or maybe to read a large CSV file or read a database or read maybe an RSS stream or
we also had this idea, although Alex, I think correctly suggested that it might not fit this template, but to have a data source that's something like Kafka or some sort of stream processing. But I think Alex correctly said that, and I agree with that might be better for another idea that we're playing with.
I think we want to do stream related stuff in the future, but we haven't yet to define it.
Absolutely. Yeah. So not only the transformations need to be flexible, but also the sources need to be flexible. So this essentially, this template is a balancing act between not providing too little utility that no one uses it, but not providing too much utility that essentially we overload and overwork ourselves in maintaining it, because that's the whole point of containers. All right, and with that, I guess you guys are always welcome to visit this PR, and I'm going to pass it back to Alex to talk about, I think, emissary.
Well, Simon, I have one tiny question.
Yes.
Because I think that doing the processing definitely requiring a lot of resource in the controller, because you said you're not using containers. That means in the controller we are doing such thing. What kind of like guidance here, like because the data could be huge when we're doing such processing. So
yeah,
okay.
So that's actually a great question. So currently the only guidance we have, well, currently this is a very naive implementation so far, but if we're not doing anything with external networking, we try to do it in memory. But like you said, you can imagine that the result of this file list is immense, right? And maybe it's so large that it could actually hold up the controller. So yeah, maybe part of the decision would be to sort of see before we decide to whether launch a pod or not, to see how big the inputs are. Maybe different functions will have different expected sort of resource use. So maybe we also take that into account. Something I would want to mention is that anything that the controller can do in memory could be done in a pod. And also users will always be allowed to force a pod. So if they think Argo might want to do it in memory, but you're like, no, I know this won't work, you can always add pod strategy always, and then you'll just launch a pod regardless.
I see. Yeah, that makes sense. So other thing I want to add to that, because I know you're using the Minio as an example for the secret loading. But for the case we are using the IAM access for such access. So sometimes running from the controller to access data is actually not feasible due to some setup. So yeah, force pod will work.
Yeah, awesome.
For artifacts, generally, I think artifacts are always going to go create a pod, but I think the controller level ones are usually for like a HTTP request would probably be done in the controller unless for some weird reason it needed to be done in a pod.
Yep, that's pretty much what I was going to say. So we pretty much have decided that anytime anything artifact related has to happen, it will happen in a pod.
I see. So that will be more like being a virtual node, but spin up a pod actually doing the job.
Yes, so that's actually, yeah, that's a great clarification. If you guys are familiar with how we do memoized nodes, we essentially, when we create a node that hits a cache and it's memoized, we immediately create a node that immediately completes. So if you guys are worried that you guys are going to have to think, for example, about I don't know if this is going to be a pod or not, and I don't know if Argo is going to treat this as a pod or not, depending on whether or not it runs as a pod. Behind the scenes, it'll essentially all be the same. So it'll essentially just be a run that ran within a millisecond, as far as Argo is concerned.
What about logs? Will those still end up going out to the artifact store, like with a pod?
That's a good question. So currently, since there's going to be no pod, there's going to be no logs. So the controller itself would have to send the logs to the artifact store. I think that's a good question, and it'll be important for debugging. Something I'll have to consider.
Cool.
All right. Handing it back to Alex. Thanks, guys.
Thank you, Simon. few people have got any more questions or queries about that, or if you want to give it a go, just
Yeah, can I just sorry to interrupt. This is Zubair. I want to second what was just said with the logs. That would be very helpful.
So to clarify, the log request is essentially if we decide to not run a pod, you guys will want the logs to be stored in the same manner as they would if they ran in a pod.
Yeah, I think so. Ideally.
Awesome. Yeah, I think that's definitely valid.
What logs are you interested for the? I understand the artifact ones would be necessary. Like if I can't download the S3 key because of permission issues, it's you need that surfaced up into the or maybe you want that log archived. But if it's something like I have a parameter and and then you're trying to do transformation, is there something about that you wouldn't want logged? Yes.
Well, suppose I input a parameter that doesn't meet, like it looks like group might expect a JSON list. If it's an invalid JSON list, I'd want to see the log. If my regex is invalid, I'd want to see logging about that. And it might be fine that stays in the controller, but it would just be nice if the logging interface behaved the same as pod steps.
I think irrespective, the reason for the transformation would be surfaced in the workflow itself. Like if this step, this data step, filtered out nothing, right, and it produced no, like your filter was wrong because your regex was too restrictive. This would produce an output of nothing. Or if the HTTP request failed because it didn't have proper like the URL was fat fingered. I think all of those errors I would expect to be surfaced in the workflow itself. So when you click on the node, it would explain why this node failed.
Unless it's an invalid regex or an invalid input. It just completely fails to process.
Oh yeah, those I also would, if your regex is not a valid regex, for example, I would expect a node in the workflow to have a red error and with a message. Yeah.
Awesome.
Okay. So just to reiterate, if you've got any more questions, if you want to try it out yourself and see how it works, drop Simon a message on Slack. Okay, so a feature coming up probably in version 3.1 or 3.2 is going to be a new type of executor for Argo workflows. Now, for those of you who don't know what an executor is the job of the executor is typically to run the particular pods in your workflow. And what happens is when you start a pod in a workflow, you typically get a couple of containers attached to that pod, one called the init container and one called the wait container. The role of the init container is basically to ensure that any artifacts you wanted in your pod are made available to you. And the role of the wait container is to actually save any artifacts you want saving back to S3 or GCP or what have you, and also kind of report back the status of your main container. So we have several different implementations of this code using different mechanisms. So one implementation uses the Kubernetes API, another implementation uses the Kubla API, and one uses the Docker CLI, and the most recent one uses process namespace sharing to get access to the data. What we wanted to be able to do was to be able to run multiple steps in sequence in a single pod. And I'll talk a bit about what those benefits were. And we had a look around for some solutions related to that. And we came across how Tekton did this. And what Tekton does is when it starts up your main container effectively, it replaces the command that you specified with a new command that then launches your original command in a sub-process. Okay, so what we've done is we've taken this and we've adapted it to how this idea and adapted to how Argo workflows does things and called it the emissary executor. Now, the emissary executor is has some slightly different trade-offs compared to other executors. So it's typically is about as secure as other executors, and it typically is about as performant as other executors. Its main downside is that if you don't specify the command that your image needs to use, the emissary cannot infer that from the image itself. So you actually need to specify it. It's only a small downside. But what the emissary can do is, because it sits inside your container, it can actually wait for something else to happen before starting your process. So what we can do is actually use the emissary executor to run multiple containers within a single pod. So let me give you an example of what that looks like. So here we go. This is a new template. I've got a new section in my template called pod, and under that has a graph. Now, none of this is concreted in stone just yet. It's just intended to be indicative of what it might ultimately look like, but the names might change. And under graph are basically 3 nodes of this graph, A, B, and C, and each of those run the Argo, say, demo, like a hello world image. And what this tells me is that container B is dependent on container A, and container C is dependent on containers A and B. Okay, let's create that. So the namespace, and then create that. What you can now see is my graph has expanded, and I can see my workflow here. Now this is would have originally had would have run 3 pods to achieve this. What this actually does instead is runs 3 containers within a single pod. There are a couple of benefits to that. The first kind of benefit is that that's a lot less expensive to launch a single pod than to launch multiple pods. I can give you another demonstration of a use case where this is going to make a big difference. So this is a workflow that contains a graph with a count of 3, and it launches 3 pods, and each of those templates runs 3 tasks. Now with version 2.12, you'd need to launch 1 pod per sequence. So say you had a sequence of 1,000 and you needed to launch 3 tasks, you'd need to launch 3,000 pods. But if you put all those pods into all those tasks as containers within a single pod, rather than having to launch 1,000 pods times 3, you actually launch just 1,000 pods. So you can actually get an order of magnitude performance improvement. Oops, let me set the namespace again. I'm sure I will do that every single time we do that. Okay, there you go. Now you can see that I've launched my graph. It's a graph containing subgraphs, and each of those subgraphs contains 3 tasks, but because each task is a container and a single pod, you can see that the execute actually, I think you can see it's visually faster than executing that. Okay, what are the other benefits of running multiple containers within a pod? Well, this is the other main use case I think that people may find this useful for, is that if you need to share some disk space between your pods, they can all have a common mounted volume and pass data between one another using that volume. And so in this example, I'm going to put some raw data onto a volume. I've just called it /workspace, and mount the workspace as an empty dir. And then that volume is mounted onto every one of my containers within my pod, and they can all use that as inter-process communication, or just multiple pods writing all there, and it produces a single output artifact created by multiple ones. And again, as I said, I would forget the namespace. There we go. We can execute that, and you can see this guy will just execute, and when he finishes, we should see some output artifacts appearing on here. Oh, maybe not. Maybe at the you can see that I bought an output artifact that's come from all that's been aggregated from all the containers within the pod. And that's kind of, I mean, to be honest, that's kind of it. It's a new executor.
Can you show the pod spec that was rendered out for one of the more complicated?
Yes. So let's have a little look here. Just gonna see if I've deleted the pods or not. No, great, good. They've not been deleted. This will be the less complicated one. And any particular bit is particularly interesting to you? I guess you asked for the spec, didn't you? So let's scroll up to the spec here. And the main thing that's going to be different is
You just hijacked the entry point.
This is the entry point here. So we replace your command is replaced with Argo exec emissary --, and then your original command is appended to that to be executed. And the code launches that sub-process. Sorry?
Cool. Other than that, this is vanilla. Cool.
There's nothing particularly sophisticated. It doesn't use any unusual technologies. It just uses a shared volume to do stuff. We've made quite some performance improvements around executors recently, but this one doesn't make any network requests to execute. So it's potentially faster than other executors as well.
Does Argo, so do all of these containers obviously start at the same time, but some of these stages should not do anything until the previous one completes in the DAG? Does the Argo exec process deal with that problem?
Correct. I actually can show you what it looks like in the logs for the particular containers. So in this graph, container B has waited for container C has waited for containers A and container B. So, oops, this is buggy. Shouldn't say that. You can see then in the outputs from your pod, it just says it's waiting on container A, then waiting on container B. And if you look at the timestamps, you can see the timestamps are slightly different between the two of them. So the first one, the second one, it waited 3 seconds for A to complete and then waited for B to complete. Then you can see the actual output. That's the actual output from your sub-process. What's now the sub-process. And finally, there's a closing comment here about the fact it's not saving outputs from that particular container because that container is not a main container.
Is that IPC between the three processes to handle that signaling, or is that calling back out to Argo? Or
so no, the way that this works is all the IPC is done by reading and writing and waiting for files in a shared volume. So there's a shared volume mounted at /var run Argo. Under that volume, there are files like template, which contains the template. Then there's a subdirectory called CTR / name of the container. And in that directory, there are files such as exit code to indicate what the exit code was of that one. Things like standard out and standard error when they're needed, which they typically aren't needed. Any outputs are captured into that directory. And so the wait container can just copy those files from that directory. And then the way that the wait happens is basically every 3 seconds, it checks to see if the exit code file has been created. If it has been created and the contents of that file is 0, then it launches the sub-process. If that file exists and the contents are not 0, then it actually exits itself. So if a previous task doesn't complete successfully, the subsequent tasks don't run.
There's only one concern is that since in the one pod there are so many containers, and then the requested resources will be the CPU, memory, those kind of stuff will be doubled or tripled.
Yeah. So what you probably don't want to do with this is start two steps, one after another, both of which have very high CPU requests and run for a very long period of time, because it will double allocate those resources. So there is a cost issue when doing this, and so it may not be the right solution in some cases. It's typically more tailored towards situations where you've got a number of pretty shorter running tasks. So this is, I mentioned this is inspired by Tecton. So CI/CD related tasks are probably more suited to this than other kinds of tasks.
Hey, so hi, I'm Jason. I'm from the Tecton team. Alex invited me because this is inspired by Tecton. One thing that Tecton does that I don't know if this does or can do. First of all, Tecton does this, but only can ever run steps sequentially. It doesn't do a DAG within the pod, at least not yet. But for the resource question, if someone requests a Tecton task that runs 3 steps and each requests 2 CPUs and 8 gigs of RAM, it's actually going to squash that down when it makes the pod, when it translates that to a pod, it's going to take the max CPU across all steps and the max RAM across all steps and request that in the first container only, and each container afterwards in the pod is like a minimal request. It doesn't do anything with limits because limits are actually enforced. But I don't know if that applies when you do things in a DAG and you don't know exactly when things will run. You don't know if two things will run together that both, do need those requests at the same time. But I bet you could be smarter about this if you know that it is going to be a linear execution of containers, and possibly even smarter if you know certain things about the DAG, for instance, and resources. So I think there's a room for improvement if you're interested, and I have experience with it, and I can help if you need to.
Thank you, Jason.
So this is really cool. I actually also had a question about the command. So in the docs, you said the command has to be specified, and I think you said that the user has to specify the command. But in your workflow requests, you just say the image. Do you look up the command from the registry? That's what Tecton does. When you don't specify a command, it goes and looks it up. But I'm curious if you've come up with a better way to do it that we can steal back from you.
The short answer to that is no. We don't do command lookup. What you can do, there's a couple of escape hatches here. One escape hatch is that in your configuration of the controller, you can just specify, you can write a list of images and then just say what the command should be for those images. So there's
Gotcha.
that's one escape hatch. The other escape hatch is that in version 3.1, it'll be possible to choose which executor you use for a particular workflow based on the label. So you'll be able to label your workflow, say use the kubelet executor or use the Docker executor. And the goal behind that is to allow people to try out different executors to see if they work, or if they don't work, that the default one doesn't work under certain circumstances, then they can actually configure the system to use a different one. So rather than just forcing you to choose from day one your kind of security performance trade-off, security capability performance trade-off, you can actually choose which one you want to use under each different circumstances. And particularly with Docker going away, as in Kubernetes, that kind of mitigates that risk on the horizon as well. Maybe a v1.1 or a v2 of this feature would include a registry lookup. I think we would look to see how complicated it is to develop that and how much demand for that one. But I would take a look at the resource request squashing and see if we can do something in that area, even if it's just kind of a poor man's solution. Is if you're using a pod template, then you need to we recommend you request. You need to determine how much to request for that, and request less than you think you might want to request for it. Because the emissary doesn't consume very much in the way of CPU and resources at all. I think it's like 2 meg or something, even quite trivial.
Yeah. About the entry point rewriting or figuring out the command, we used this technique in the Argo v1 like 3 years ago, and the way we tried to do it then was we actually did a Docker inspect as a part of a init container to figure out what the entry point is, but that actually had its own problems in that it in the init container you had to actually download the image and then inspect the command in args, and then you could figure that was, I think the registry lookup is probably lighter weight, but that was another technique we used in ancient times.
The registry lookup, Tecton does a registry lookup. The downside to, and it's not terribly complex, the real downside to it is that it does the lookup from the controller, and so if it's a private image, you have to give credentials to the controller to look up the entry point of that image, and like there's only one controller, and so you end up with this like all-powerful, can read many images it shouldn't have necessarily access to, all-powerful controller. We have looked at looking up the command on the node, basically doing a Docker inspect, what's your command, and then running that. I don't know that we've decided to do it or not to do it, but it's good to know that someone else has already done it and doesn't seem to completely hate it as an idea.
We sometimes, so my philosophy is, often it's better to develop the core capabilities of a particular feature and then see what people come back for and ask afterwards. So don't try and develop every single feature for your product, develop almost deliberately underdevelop a particular feature. And then when people come back to you asking for more, then you can give it to them. And like an example of where I've done that in the last year is the SSO integration. That was deliberately written as a very very minimal implementation. And there were like 2 medium-sized things that needed to be added to that afterwards to actually really fill that feature out properly, which was the support for JWEs and the support for email and email confirmation claims. But I don't think I would necessarily have been confident that people needed that unless they'd been deliberately underdeveloped.
Alex, there's a question in the chat. It says, would we be able to have daemonized containers as part of the container dependency graph?
Interesting question. So obviously you can use sidecars with this. So not only can obviously you run 3 main containers, but if you also want to run sidecars, you can do that as well. And actually, one of the biggest challenges around writing executors is very little to do with wrapping processes up. It's actually things about correctly dispatching sig term and sig kill to containers when they need to. It's actually quite difficult to do. You know what? I haven't looked or tested it with the daemons, so I will do that.
So yeah, I guess I would like to clarify, or ask Dylan to clarify. So we have the daemon container feature, which actually launches a separate pod. That should obviously just work because it's a separate template type. Not template type, but option in the template. Are you asking about the sidecar use case, Dylan? I'm not sure if you can speak or if you need to chat, but.
Add that to my list. That's the kind of questions that are really useful with stuff like this.
Daemons that depend on each other. So you clarified about that, daemons that depend on each other. I think that would just be nodes in the graph that have dependencies, I guess, but it would imply that they complete. So to me, that's a little bit of an oxymoron to have a daemon dependency, unless you're talking about startup time. Yeah.
Okay, any more questions? I'm a bit aware we're over time today, but I think we're having some good conversations and I'm quite happy to keep going. People haven't dropped off, which in great numbers, which normally happens. Okay.
Oh yeah, he was saying about startup. So daemons, so probably sidecars with a startup dependency between them. That I don't think we accommodated for.
Yeah. I just realized I've missed a question about that. So people are asking about running Python inside the controller as well. But let's circle back around that. I haven't talked about anything about plugins in this session, so it's not because it's not a fully developed topic for us yet. But there may be ways to plug in things like Python in the future. Okay, so next on our menu for today is another new feature in Argo Workflows 3.1 called Conditional Artifacts Templates, which Bala is going to talk about. Bala, are you ready to take over?
Yes.
Thank you very much. I'll let you grab the screen.
Yep. So, hi everybody. I'm Bala, engineer in Argo team. Are you guys able to see my screen? Or not? So.
Yeah, we could see it.
Are you able to see my screen? Yes. Okay.
Yes.
Hi, I'm currently working on the feature called conditional artifact and parameter logic. So basically, currently there is no way you can specify the step level or DAG level artifact or parameter if one of the step or DAG has a when conditions. if you specify any step or a task artifact which didn't run, then the workflow will fail to say that, hey, I couldn't find an artifact. So the motivation here is like, we need to have like a condition-based picking the artifact or parameter based on the parameter or conditions. So that was the motivation. We started working on that. So the spec change. So there is a new field called from the expression. There you can write a full conditional expressions with conditions like whether the true or false. Based on that, you can pick up the which artifact you need to assign to that particular output artifact of the step, or you can have like arithmetic operation, anything you can do that here, because this is the Explorer language which will support like all the expression conditions. So this is mainly for the artifact. So this example mainly like it's a coin flip example which has like a two-step, has like a when conditions. So based on the value, that particular step will pick that artifact from the head or tail. So this is that artifact scenario. If you go to the parameter scenario, this is a little bit different than the artifact element. Like we already have a value from element in the parameter, so that we added a sub element called expression. There you can completely write the expressions to pick the values. So here another one thing, even you can have like a hard-coded value or arithmetic value, like a plus b or like all the arithmetic operations, or you can refer that the step output here. So this is like a Fibonacci series with a recursive model. So we are able to achieve using our expression, the conditional parameter expression. So that's a quick things. You can expect this feature in the 3.1. So that will open up like instead of hard coding or only choosing a one artifact or parameter, you can have like a full-fledged expression to choose the artifact or parameters from the previous step. That's it from my side, because given time, next meeting I will do the demo for you guys. Do you have any questions? If no, I will hand over to the Alex.
Thank you very much, Bala. And to just close us out with the final topic for today, Derek is going to talk a little bit about Argo Events, upcoming features. Derek, over to you.
Yep, thanks. I know we have been over time for a lot, so I'm gonna make it quick. I have nothing to share, but just want to give a heads up about the new features in the next Argo Events major release 1.3. The first feature we're going to have is the permissive metrics. And in the new event source and sensor pod, we will have a metrics endpoint exposed, and then your permissives can scrape those metrics, and then you'll know those things like how many actions your sensor has been triggered. Let's say if you use a sensor to trigger a workflow, and then you know how many workflow this sensor has created, and also include those things like how many events your event source has been received, or is there any error when you trigger action, things like that. And then for the configuration stuff, your permissive operator, if you use permissives directly, and then you need to configure like pod discovery mode for the arguments metrics. If you use permissive operator, you need to configure a pod monitor stuff. That's for the permissive metrics. Another thing we're gonna include in the next release for arguments will be a validation webhook. We introduced a validation webhook for arguments. Currently, if you have any issue with your YAML file, let's say your event source is invalid or your sensor is invalid, and then you have to wait you have to apply the YAML file first, and then you need to check the CR object status to see if there's any error, or you need to go to the controller logs to see if there's any issue with the reconciliation. But with the validation webhook, and you will know if there's an error in your YAML file right after you apply the YAML file, and then return to your terminal directly. And that's one benefit. Another benefit is like we actually have some immutable fields in the CR objects. For example, the event bus authentication strategy. That field is actually immutable. If you already have an event bus with authentication strategy to be like none, which means there's no auth strategy, and then you want to change the token, and then you will be a disaster for the event source sensor part. So actually, we don't want that field to be changed. So with the validation webhook, and then it will prevent you from doing that. So that's a benefit for validation webhook. But right now, the validation webhook will be an optional extension for installation. It's not mandatory. You can choose to install or not install. It's up to you. And I think that's it. I'll get it back to Alex.
Brilliant. Thank you very much, Derek, for that today. Thank you very much, everybody, for staying for an additional 30 minutes today, and hope you got a lot out of it. If you want to follow up with any questions, obviously come and find us in the Slack channel, ask the questions. We often happy to create you an engineering build if you want to try out a new feature and experiment with it as well, to give us feedback on that feature. It's very valuable for us to just get people's thoughts and ideas on things we develop. Thank you to all our presenters today, especially to Alexandre and to Ang for their fantastic presentations earlier on. It's very interesting to learn about how different people are using Argo workflows. And if you are interested yourself in coming along and presenting at the Argo community meeting, or being involved more in things like writing blog posts, coming and doing guest blog posts, or any other kind of material, we more than welcome that kind of stuff. It's a great opportunity for you to talk to the community about your stuff, and a great opportunity also for you to get a bit more exposure about what you're doing. Finally, this meeting will be recorded and uploaded to YouTube, so you can share it with your colleagues tomorrow. And I'll drop the link into the YouTube, into our Slack channel, probably sometime tomorrow. Our next community meeting is the same time next month, though I do plan to do a short working session on Argo workflows and security, and around configuring workflows for security, and I'll let you know more about that soon. Okay, have a lovely day.
Thank you, guys.